Hey everyone. Okay. Hey everyone, this is WebDev Sumos, and today we are going to look at Dijktra's algorithm. I'm going to try to understand what it is and what we should be exactly doing. So I'm on Neetcode.io, and he has like made this Dijktra's algorithm one available for free. So yeah, I'm just going to try and go over it and try to understand what it is. And yeah, it's a long time pending question. And yeah, so let's get started. Hopefully this is good enough viewport, like the window size. Yeah, this one. So here we go. Yeah, implement Dijktra's shortest path algorithm. Given a weighted and directed graph and a starting vertex, return the shortest distance from the starting vertex to every vertex in the graph. Return the shortest distance from the starting vertex to every vertex in the graph. Okay. So input is n, the number of vertices in the graph. Okay. Vertices are nothing but the node, where 2 is less than equal to n and n is less than equal to 100. And each vertex is labeled from 0 to n minus 1. Okay, 0 to n minus 1. Okay, got it. So edge is a list of tuples, each representing a directed edge in the form UVW, where U is the source vertex and V is the destination vertex, and W is the weight of the edge, where 1 is less than equal to W and W is less than equal to 10. A source, the source vertex from which to start the algorithm, where 0 is less than equal to source and less than n. Note, if a vertex is unreachable from the source vertex, the shortest path distance from for the unreachable vertex should be minus 1. Okay. So I'm really sorry, I was zoning out a bit. I was thinking about something else. Don't mind if I go over the question one more time, read through it one more time. So I know that given a weighted directed graph and a starting vertex, return the shortest distance from starting vertex to every vertex in the graph. Okay, where inputs are n, the number of vertices in the graph, where n will be always there will be 2 nodes and less than or equal to 100 nodes. Each vertex is labeled from 0 to n minus 1. Edges, a list of tuples, each representing a directed edge in form of UVW, where U is the source vertex, V is the destination, and W is the weight of the edge, where okay, the source vertex from which to start the algorithm, where 0 is less than equal to source is less than, okay, got it. If a vertex is unreachable from the source vertex, the shortest path for the unreachable vertex should be minus 1. Okay, got it. So there are paths from each node. Okay, so these are edges that have been given to us. So each edge is representing, okay, so source is 0. We want to identify, okay, so 0 1 10, 0 2 3, 1 3 2, 2 1 4, 2 1 3 8, and 2 4 2, and 3 4 5. Got it. Got it. So edges are, excuse me, sorry. Okay, So let's see. So can we make a adjacency list out of this one? If we have a directed graph with us, can we make a adjacency list? Is that um, is that okay if we make a adjacency list? Will that be helpful in traversing this graph? Mhm. So let's say if we create an adjacency list of this graph, then I can visit from the source node, whatever my source node is, I can start traversing from there. Okay, so okay, and the uh, output returns an object. So output is an object of object. Got it. So 0 0 will be 0, 1 will be 7. Okay, so we have to make sure. So what we can do is we can simply um, create create an object, or yeah, we can create, let's say we can also create an array of n, and what we can do is, yeah, what we can do is that we can start assigning the values to it. So how can we um, go about storing the um, values for the adjacency list? Okay, so what we can do is we can assign initially everyone to -1. Okay, and and I'm also thinking that once I start from my source node, if I have the adjacency list created, I can visit that node and calculate the weight um, by which I can reach that particular node. Okay, I can calculate. So let's go to the Miro board. So I'm thinking I can spend 1 hour understanding this thing. I'll spend about more 10 to 15 minutes on my brute force thinking, or whatever my mind is thinking right now. So I'll do that for like 15 minutes more, and we'll jump onto the video explanation from Neetcode. Yeah, so that is what my plan is for this one. Let me just let me see if my boards are synced. I don't want them to be out of sync or something like that. Yeah. Oh, Miro will be having downtime on November 11. Okay, so our board is empty now, and then what we can do is, let me write hello first, and let's see where the hello is popping up. Okay, let me go back here and just note down, sorry, 0 1 2 4 3 8 2 5 and 4. Okay, so the I've created my nodes, and let's see this. My adjacency list would be from 0 I can reach to 1 with weight of 10. I can reach to 2 with weight of 3. From 1 I can uh, reach to 2 reach to 3 with a weight of 2. From 1, that's all the areas I can reach. So 2, 3, 4. Oh, sorry, I didn't switch the, yeah. So 4, yeah. From 2, what I can reach out is uh, from from 2 I can reach out to 1 with weight of 4. I can reach out to 3 with a weight of 8. I can reach out to 4 with a weight of 2, and from 3 I can reach out to 4 with a weight of 5 and nothing else, and from 4 I cannot reach to any of the nodes, so 4 will be empty for that matter of fact. Okay, 4 will be empty. So this would be all. Okay, so for simplicity's sake we'll keep yeah, like this, and also get rid of this. Okay, so yeah, we'll start with 0. Then I guess whenever we are finding the shortest path, uh, we have to use BFS, breadth first search. So will that be applicable in this case? So if I keep my 0 in the queue, and yeah, if I keep my 0 in the queue, so what will happen? And if I then shift my 0, and I should also keep a track of 0, 1, 2, 3, 4, right? These are my nodes, so everyone will be -1 initially. So as soon as we pop 0, our source, I guess we should keep it as a 0 thing. 0, yeah. So we shift 0, and then what we do is we see that 1 is there, then we add 1 to the list, and we calculate that from 0 we can reach to 110. So it won't be -1, it should be infinity, right? Infinity, infinity, yeah. And if we see if there is smaller than the current value, then we'll change it to 10. Okay, then we also reach to 2, and 2 2 is like uh, we can reach 2 with 3. Okay, and then we shift our loop, then we kind of um, get rid of 1, like we'll traverse the 1, and then we'll see that we can reach out to 3, and the distance to reach there is yeah, I guess we also need to keep track of what is the current um, distance of 1 that we are traveling from. So 3 plus 3 3 plus 2 sorry 10 plus 2 would be 13, so we'll update, sorry, 12. 10 plus 2 is 12, so we'll update to 12 this guy. And then, yeah, then we'll traverse 2. um, Once we are traversing 2, we'll find out the 1 again, so we'll add 1 to the queue, but this time we'll check if how can we reach to 1 via 2. So 2's value is 3, plus the current weight of 4. 4 would be, and I guess we should be deleting everything that we have already visited. So this guy, this guy, this guy, we have to delete it, right? We have to delete them. Okay, so because we don't want to visit them over and over again. Yeah, so, or can we reach out to them one more time? I'm not sure, but let's see. I see 1 is there, so 3 plus 4, 2 is 4. We can reach to 2 from 0 with weight of 3. Then 3 plus 4 is 7. 7 is uh, less than the less than the 10. Then we update this to 7. Okay, and then we check the next one, the next element of this, which is 3 again. We can reach out to 3 via 2 also. So 8 plus 3 is 8 plus 3 is 11. Then that is shorter, so we update it with 11, and we add this to our queue. And lastly, 4 and 2 are there. 4 and 2 are there, so um, from 2 we can also reach out to 4 with 5. Sorry, 3 plus 2 is 5, so this will get updated to 5. And we'll get rid of the 2 from our queue as well. Then we get 3. We'll start reversing 3. So from 3 we can reach to 5 using so what is the minimum weight of 3 that we can reach to 3? It's 11. 11 plus 5 is 16, and we have already seen a better value at 4, so we won't update it. Okay, we won't update it in that case. So yeah, 3 will also be removed and nothing will be added onto the queue. And one will check 1 if 1 can how can we reach from 0 okay, yeah, so we have to now check for 1. We see that from 1 we can reach out to 3, so is that the minimum distance to reach 3 is 7 plus 2, that is 9. Yeah, so if we take that route we can obviously update R3. So we update R3 to be 9, and we also add 3 also add 3 again to the queue. Okay, yeah, and then get rid of this, 1, then we go to the 3, and then can we reach from 3 to 4 in minimum amount of time? uh, so 3 is already 9, 9 plus 5 is 14. We cannot, so we don't do anything. So 4, 4 has nothing to be traversed. Then 3 comes again, and from 3, uh, where can we reach 4? But it's again smaller, so we don't do anything, and finally we are out of it. So is the answer this guy? Sorry, I lost the track of it. So 0 is 0, 1 is 7, 2 is 3, 3 is 9, 4 is 5. Oh, yeah. So I guess this is it. I guess I can implement this. Yeah, I can implement this. So let's try to implement this. I guess BFS is the one that we have to use, but if I'm wrong, then we can definitely look at Neetcode's solution. Uh, okay. So excuse me. So we have been given the shortest path. Yeah, shortest path n is given to us. So what I can do is, for let I is equal to 0, I is less than edges, n, I plus plus, I know that let result is equal to an object in which I have to create an object of 0. Why is there is an object of object? Can't we just keep it 0 comma? Okay, let's try to keep it this way. And let's create let inf is equal to number dot max safe integer. Okay, and I want to create result of I equals to inf for now. Okay, so we are setting this up, initialize everything to be infinite distance, infinite distance. And yeah, if that is the case, then it's okay. So once I've initialized it to infinity, the next thing I should be doing is I should be also creating the adjacency list, right? So that's what I want to do. Create adjacency list. So how can I create adjacency list? So obviously I have to traverse so yeah, while I am also creating this, I'll create let adj list is equal to new map. I'll use a map for this, and then adj list dot set one I comma an empty array. Okay, so edges dot length of I plus plus, I have to traverse the entire edges, right? So Yeah, what I should be doing in this case is adjacency list dot set. I'm not sure if this will work in this case, but I edges of z, z I of 0, I of 0. So first of all, let's destructure everything. um, parent node, child node, and weight is equal to edges of I. Okay, so that we don't have to write everything in that order. Parent node, comma, adj list dot get parent node. Okay, you know what, I'll just do it do it this way. Edj list dot has parent node. If they have the parent node, then what I'll do, temp is equal to adj list dot get parent node, and then temp dot push child node and the weight associated with it. Okay, and then adj list dot set adj sorry, the parent node and whatever the temp we have already set. So this is what we'll do. And the next thing else, if it is not at all, if it is a new one, then set. My camera is about to die, so I'll reset it. But yeah, where were we? So parent node, and we'll just set whatever the child node that we have and the weight associated with it. So yeah, that's we have created the adjacency list doing this. And the next thing is that whatever the result we have, result of I of source, we have also given the source, right? Source is equal to 0. We'll set that. And while we have to also get a q, let q is equal to, we'll give it the source, and while q dot length is there, then we have to be performing this operation, right? What I'll do is let node is equal to q dot shift the node, and what we need to do is traverse the entire thing for let I is equal to 0, I is less than let adjacent node list is equal to adj list dot get get the current nodes list, whatever the current node is holding. I want everything from there. So adj node list dot length I plus plus. So I guess we won't be deleting anything, but yeah, so what we need to do is yeah, till this point I'm totally sure that I'm doing it right. So first of all, let's destructure whatever we have, the node, so the child node and the weight associated with it. Okay, so we'll take out that. um, yeah, so adjacency node list of I will give us that thing. Okay, so once we've got the child node and weight, we will update the result of I. Result of I is equal to math dot minimum of result of the child node, basically child node and child node result of the parent node plus the weight, right? That's what we have to do, plus the weight that we, so 0 plus plus 10 would be given to 1. If you see right here, 0 plus 1, 0 plus 10 should be given to 1, 0 plus 3 should be given to this guy. So once that is done, a result of child would be updated. Or wait a minute, instead of doing this, why don't I just do this? If result of child node is greater than result node plus weight, then we need to do this, right? Then we need to update this, right? Then we need to update this, and also what we need to do is add that child node to the queue. Push that child node to the queue. Cool. So we have done that. But if there is a cycle, then this how we will make sure that if there is a cycle, like I'm assuming that there won't be a cycle in this one, but yeah, that's what I'll do. So once I've done this, then result child node plus weight, result child node equal to mat dot min result child node. Okay, so I'll push it, or else do we need to push it anyways? Or I don't think so we need to push it if the value is, you know, smaller. In that case we won't push it to the queue, but other than that we'll push it. And yeah, we don't need this then, because we know that this guy is smaller. So instead of calculating this over and over again, let current weight is equal to this guy, current weight okay, so we'll do that. And yeah, so that should be it. And let's dry run through this. So I come in here, 0 is there, I found 1, then 1 is infinity, I'll update it to 10, I'll update 2 to 3, then I will go to 1. From 1 I can see that 3 is there, so whatever my current weight is, that is 10, um, I'll add it to the current weight of 2. Okay, so yeah, I'll update 3, add that to queue, then I cannot go anywhere, so I'll come to 2. So 2 sees 1, so 3 plus 4, then it gets updated. So 3 plus 4, yep, then it gets updated to to 7, then that is added, then 3 8, this gets added also again, and 3 this also gets added again, then 2 gets out, so 3 comes in. 3's weight is 3's weight is 11 at this point. 3 can only reach out to 4, but 4 weight is, so 4 is not added, 3 is out. Then we've also added 1 from the earlier thing, so 1 can reach out to 3, and 3 plus 4 is 7, plus 2 is 9, so this gets updated, this goes in again. Okay, so I guess this will work, and what we'll do is, finally we have to return the result. Oh, not here, but here, return result. So let's do this. Let obj instance is equal to new solution. Okay, so what we'll do is obj instance dot shortest path, and we'll take this everything from here. We'll also assign it some values. Let pass those n edges and so source to this guy, and also console log whatever the answer that is going to be generated. And let's can we run this? I guess we cannot run this, we only can submit this. Okay, so yeah, it got accepted for most of the test cases. I might have missed couple of test cases, but my thought process was somewhere close to what Dijktra's algorithm is there, and I'm happy about that. But I am excited to see. I just wanted to you know get my thought process running for this particular problem. I always wanted to do this problem, but yeah. So I guess the conditions that I might not be looking at might oh yeah, okay. So what I need to do is, before returning result, for let I is equal to 0, I is less than n, I plus plus, if result of I equals to inf, then result of I equals to -1, put -1 there, and if I submit that now, oh, everything got accepted. That's great, because yeah, oh, is it what I'm thinking it is? if that's the case, then that's great. That's really great. Okay, so that is it for this one, guys. In probably after 10 minutes or so, I will I will jump back to the video part of the solution and try to do that. But yeah, I'm really happy that I was able to talk talk through the solution um, to a calculation here. So yeah, it does really help. But yeah, let's circle back to this question in like 10 15 minutes. Okay.